Hi! This lesson is about reflections. If you remember, a reflection is just one of the three different ways that you can actually move a shape or a figure or a design around the coordinate plane. In a reflection, a figure flips across a line. That's why a lot of students actually call reflections flips, right? And in elementary school, which was probably the first time you ever worked with reflections, they probably didn't even call them reflections. They probably called them flips. So, and you know, that's okay. That's a good way to think of it. I like to think of reflections as the process of, like, when you're making pancakes and you have your spatula. If you can imagine that you're using your spatula and the shape is a pancake, and you're going to take your spatula and you're going to pick this pancake up and you're going to flip it over to the other side. And when you do that in geometry and math class, when you reflect a figure across a line, what ends up happening is that the figure ends up in a new position and kind of facing the opposite direction as it was originally. So translations, which are slides, which we've been doing for a few days prior to this, the shape doesn't ever change position really. It doesn't flip, it doesn't turn, it doesn't rotate or any way. Well, you're going to see today that the shapes actually do look a little bit different when you make the reflection. You will still end up with congruent shapes, same size, same figure, but it will be facing a different direction. So if I were to illustrate a reflection for you, just one right off the bat here, I have the y-axis and the x-axis there showing the coordinate plane. I have triangle XYZ here on the left, and I am going to reflect it or flip it across the y-axis. Now, it's all about the vertices, right? The vertices are the corners. And once you identify the line that you are flipping your figure across, so in this case we're going to flip it across the y-axis, the trick to it is to count how far away the points are from the line that you're flipping it across in which direction. So for example, if I'm going to look at X, this vertex, and if this were really graph paper, you know, I'd be able to count how many units away X was from the y-axis. It might be 1, 2, 3, 4, 5, 6 units away to the left. So if I wanted to put X on the other side of the y-axis, if I wanted to flip it across the y-axis, I would move it 6 units to the right. 1, 2, 3, 4, 5, 6. And this would be my new X, and I would call it X prime. And then you do the same thing for Y, and the same thing for Z. So Y down here is also 6 units away. So I would move it 6 units away this way. 1, 2, 3, 4, 5, 6. And there would be my Y1. And maybe it looks like Z is 1, 2 units away. So I'm going to move Z 2 units away. 1, 2. This is my new Z prime. So now I connect my new vertices. Oops. Let's make that red, should we? Yes. And there is my new image. So just like a pancake, I flipped it, or I picked it up and I flipped it across the y-axis. Now it is still the same shape, it is still the same size. If I could cut these guys out and lay them on top of each other, they would match up perfectly. But you can see that because it's a reflection, because it has been flipped, it appears to be facing the opposite direction, if you want to think of it that way. And let's not forget that when we do draw our new image, right, that's what this guy's called. It's called the new image. We have these little notations here. X prime, Y prime, Z prime. That's what tells us that that is our new shape. Let's see what's next. Here are kind of the step-by-step directions. How to make a reflection. Graph the original figure. Reflect or flip or move each point on the original figure across the line as directed. And the directions will always tell you what line you're flipping it across. Then you're going to connect your new points or your new vertices to form the new image. And just a reminder, these will be the ones that'll have these little notations. And then your new image will be congruent to your original figure. Really? This really isn't all that difficult. There's just one little snag that might slow you down here in a couple slides. Let's take a look at one. Graph each figure and its reflection across the x-axis. Okay, so this is important. Tells us that we are going to be reflecting across the x-axis. Now the x-axis is the one that goes horizontally like so. Then you can see it says, list the coordinates of the vertices after the reflection has been made. All right, so first of all, we have to graph our original shape. Then we have to reflect it across the x-axis. Then we have to list the coordinates or the ordered pairs for our new points or our new vertices. So here's the original figure, A, B, C. Well, just to save some time on this lesson, I went ahead and already plotted A, B, and C. So A is over 5 up 2. Here's A. B was over 1 up 3. And C was left 1 up 1. So there's my original figure, and it is a triangle. We are supposed to reflect it across the x-axis. This is the x-axis. So now we're going to take this thing from being above the x-axis, and we're going to pick it up with our spatula, and we're going to flip it down just so that it is now below the x-axis. And it's all about counting units. How far is each point away from the line that you're flipping it across? So let's focus on A. If I'm looking at the x-axis, A is currently up 2. So when I flip it, it is going to be down 2. This is A prime. B is currently up 1, 2, 3. I'm going to make it go down 3. 1, 2, 3. B prime. Over here at C, C is currently up 1. C is going to go down 1. C prime. Connect A prime and B prime and C prime back to A prime. And that is a congruent triangle. I simply picked it up with my spatula and flipped it down across the x-axis. Now the directions also said to list your new coordinates, which are your ordered pairs. So let's do that. Where is A prime, B prime, C prime? Remember, we always list the x coordinate first. So starting at the origin, how do you get to A? You go over 1, 2, 3, 4, 5. So going right 5 is a positive 5, and then you go down 2, which would make a negative 2 for the second number. The coordinates for B, again, back to the origin. B is right 1, so the first number is a positive 1. And then B is down 1, 2, 3, so a negative 3 for our second number. Trying to get to C from the origin, we would move left 1. So that's going to be a negative 1 for that first number in the ordered pair. And then C is down 1, so negative 1 for the y coordinate. And those are your new ordered pairs for your new image. Here's our next one. Graph the image and its reflection across the y-axis this time. All right. Remember the y-axis is y to the sky. So that would be that line. And then list the coordinates. So again, I've already plotted the original figure. KLM. KLM has already been drawn for you. Here's K, here's L, here's M. Now, it's going to go across the y-axis. That's this guy. So instead of being on the right side of the y-axis, we're going to flip it so that it's on the left side. Everybody is the same units away, or the same number of units away from the y-axis, except in the opposite direction. So if I'm looking at K, K looks like it is right 2 from the y-axis, so now we're going to go left 2. K prime. L, 1, 2, 3, 4, 5 to the right, so 1, 2, 3, 4, 5 to the left. L prime. M, way down here, 1, 2, 3, 4 to the right, so 1, 2, 3, 4 to the left. M prime. Connect all of my new vertices. And there's my new image. Yep, it looks congruent. It just looks like I picked it up and flipped it over. Let's list the coordinates for K prime, L prime, M prime. Where is K? From the origin, which is right there, you would go left 2, so that's a -2, and then you would go up 3, +3. How do you get to L from the origin? You would go left 5, so that's a -5, and then up 1, so a +1. To get to M from the origin, left 4, so a -4, down 2, -2. Those are your new coordinates for your new reflected image. Now this is the little snagging spot that I talked about earlier. It says, graph the image and its reflection across the line where y equals 1. Oh boy. I hope you're paying attention because this is new learning for sure. Where is y equal to 1? And in blue I typed, draw a line across where y equals 1. Okay, across, which means this way, right? Horizontal. So first of all, we need to do that. Here's my coordinate plane. I already plotted the original figure there. Now, where on this coordinate plane is y1? Well, here's your y-axis, and right here is where y is 1. The line where y is always 1 goes like this. On this line, no matter where I am, for my x's, my y is always up 1, up 1, up 1, up 1, up 1, up 1. This is the line where y equals 1. So that is now the line that I'm going to use to reflect my my shape across. I'm not reflecting it across the x-axis. I'm not reflecting it across the y-axis. I'm reflecting it across this line where y equals 1, which is where y is 1, right? You just go up 1 from the origin and put a point and draw the line that goes across through that point. Okay, so now we can move our points. Since I've already plotted the original figure, let's look at B. How far is B from that mark right there? It is down 1, 2, 3. So you're going to go up 1, 2, 3 from the red line. 1, 2, 3. This is B prime. How about C? Well, from the red line, from here, C is down 1, 2, 3, 4. So now you're going to make C go up 4 from the red line. 1, 2, 3, 4. Here you go. C prime. Again, focusing on the red line, let's look at M. So from here, M is down 1, 2, 3, 4, 5. So M is now going to be up 1, 2, 3, 4, 5. This will be M prime. And from the red line, H is down 6. So H needs to be up 6 up here. H prime. Connect all your new vertices, and there is your new image. It has been reflected across the line where y equals 1. And now it did say to list our new coordinates. Let's list them. We have B prime, C prime, H prime, and M prime. Okay, from the origin now, so back from here, how do you get to B? Right 1, which is positive 1, up 1, 2, 3, 4. How do you get to C from the origin? You go right 1, 2, 3, so positive 3. Then you go up 1, 2, 3, 4, 5. How about H prime? From the origin, left 1, so that's a negative 1, up 1, 2, 3, 4, 5, 6, 7. And M prime would be left 1, so a negative 1, up 6, right? 1, 2, 3, 4, 5, 6. Yes, positive 6. So it definitely gets tricky when we are reflecting a shape across a line that is not the x-axis or y-axis, right? There's a lot more work involved when you're reflecting a shape across a line that you first have to determine and draw. Now this one's interesting because in this particular example, they really don't even want you to draw it out. So they're asking you to really think hard and use your brain. It just says list the coordinates of the vertices after the reflection. So they give you a shape here, ABC. It's got 3 corners, so we know it must be a triangle. But they don't even want you to draw it. They just want you to try to figure out mathematically where would the new coordinates be for A prime, B prime, and C prime. It says do not graph. Think about where the new points and vertices would be. Okay, so what are we reflecting this thing across? Well, across the line where x is 3. Oh boy. The line would be vertical where x is 3. Okay, I'm going to just real quick draw a coordinate plane for you. Okay, remember this is your x-axis, this is your y-axis. Where would x be positive 3? Where would x be positive 3? 1, 2, 3. Right there, right? Isn't x 3 right there? The line where x is always positive 3 looks like this. This is it. On that line, you are always over 3, over 3, over 3, over 3. Doesn't matter what you are up or down, you're always over 3. Okay, so whatever this shape is, this triangle ABC, which we are not going to draw, we are going to reflect it across the line where x is 3. So think, looking at A, looking at the x, right here, in this point, A, the x value is positive 2. Where would that be? It would be 1 unit away from where x is 3, right? Because in A, x is 2, and we're reflecting it across the line where x is 3. So this would really be 1 unit away. So if you were to reflect it across that line, and it would be 1 unit away to the other side, wouldn't it? Wouldn't it fall over here? Wouldn't that be A prime? So if A, when we originally had the coordinates, if the x value of A was 2, and now we're moving it across the line so that it has to be 1 unit away from the 3, can you imagine what A would become? It's kind of hard to think about, and it's certainly even harder to explain. A would become 4. And the y value wouldn't change at all. It would stay at 2. What about B? Well, B, its original location for x was over 2, just like A. B would be like there, which again is 1 unit away from the line where x is 3, so it needs to be 1 unit away to the other side. This would be B prime. So what would the value be at B prime for x? It would be 4, just like it was for A. Let's think about C. C is located where x is 3. Wait a minute. X is 3? Isn't that the line we drew where x is 3? Yes, it is. That means it would be on the line. That would be C. How do you reflect something across the line when it's already on the line? Well, even if you were to pick it up and flip it over, it would land on the line again. So it would not change. Interesting, huh? Well, that'll be something that we probably have to spend more than one day thinking about during class time, okay? No worries. Last slide. Write a rule, it says, write a rule to describe what's happened here. Oh boy. Can you tell which one is our original figure? It's the black one, huh? A, B, C, that's your original figure. And the red one, A prime, B prime, C prime, that's your new image. Now obviously it has been reflected. It's obviously been picked up by that spatula and flipped over because it's definitely pointing a different direction now. But what did they reflect it across? I don't think they reflected it across the x-axis. No. And they didn't reflect it across the y-axis. Can you see the line that would be the point of reflection or the line of reflection? It's right here. Oh boy. How would you describe that line? Where is that line? It's always passing through here. No matter what, it is always from the origin, left 2, left 2, left 2. So this line is called x equals negative 2. That tells you the line that we reflected it across. But if we look at our original image and we look at our new image, does it look like everybody is the same number of units away? Well, I just caught a mistake. Do you guys see the mistake? This should be the B, huh? And this should be the A prime, huh? Sorry about that. Mistake, mistake, mistake. Is B 1 unit away to the left and 1 unit away to the right? Yep. How about A? 3 away to the left, 3 away to the right. And C, 1 to the left, 1 to the right. I think this is correct. The rule is that we reflected it across the line where x equals negative 2. That's all new learning. It's good stuff. We'll spend 2 days working with these ideas in class. And also, just kind of as a little experiment, I put a little link on here for a YouTube video. I'm not sure if you'll be able to click on this little globe to view this video or not. Give it a try and let me know next time you come to class if you're able to see this YouTube video about different transformations. All right? Thanks for watching.